Hello and welcome to our webinar today. It's the first in 2021 and good to see all of you. And today we will talk about the sugar industry and about the sugar beet, and we will have a presentation on the solutions of our UWT measurement devices for the sugar industry, and what we already did, so what we already implemented in the sugar industry, and just to give you a short overview of what is possible and how we can use our measurement devices for the sugar production. So today, Julian Bareth also will join the webinar. So I will start the first part, just about some, maybe some basic things, and Julian will then go into detail with all the applications and the success stories we already made for the sugar industry. So, as you know, sugar can be produced on the one hand with sugar beet and on the other hand with sugar cane. So these are the two raw materials sugar is made of, and what you can see here is that sugar cane makes 80% of the world's sugar market. So around 140 million tons of sugar are produced out of sugar canes, and they are grown in warmer and rainy regions like Latin America, Asia, or South USA. And the sugar cane grows again after harvest. And on the other hand, sugar is also produced out of sugar beet. So this is around 20% of the world sugar market. So 40 million tons of sugar are produced out of sugar beets, and they grow in cooler and more northern climates like in Europe, Canada, or northern US. And the sugar beet needs to be newly sown after harvest. So the basic differences between those two raw materials. And once the sugar beet or the cane is shredded or sliced, the producing process is very similar. So either you produce sugar out of sugar canes or sugar beets. So this is quite the same process then. What is a sugar beet? What are the elements? So a sugar beet consists out of a lot of water, so 72%. What is in the sugar beet is water, and this is during the process is reused several times for washing processes and also for the sugar extraction. So a lot of water in such a process. And the real sugar, what makes 17%, so white sugar, so this is for industrial use, and what we normally know for our daily use is the refined sugar. So out of one sugar beet consists out of 17% pure sugar. And there are also some side products for the sugar beet. So we have 7% beet pulps, and they are processed to animal feed. So animal feed is also made out of sugar beet. We have 3% molasses. This is used for as a raw material for different industries and also for the animal feed production. And 1% is then a fertilizer, so carbocalc, and this is used for the agriculture. So you can see sugar beet is quite versatile, and you get a lot of products out of such a sugar beet. How does a process look like? So this is basically, what happens inside a factory. I don't want to go too deep into detail into the different steps. There are many YouTube videos which explain this process way better than I could do it. So this is just a short overview of how it works, and Julian will then go a little bit more into detail about which applications we can solve there, and we have here for our level measurement devices. And not to go now into detail to this process, just to have a short overview that there are many steps and also many applications waiting for level measurement devices. So where can we use our level measurement devices? So we have the different process steps. This is what we try to describe a little bit. So in the sugar industry, we do have some storage processes. So these are silos, tanks with raw materials, or also with finished products. Then we do also need to transport all the materials to buffer tanks, pipeline, or conveyor belts. What we also have during a sugar production process are some exits, so the side products and the aggregates, so animal feed, molasses, fertilizer, lime. We have water, we have a steam production, so steam is used during the production process. And we do also have different types of sugar with different properties, so syrup, sugar crystals, raw sugar, and all with different properties. And the P is the processing. So there are some process vessels, so some process steps. So the sugar beets get washed. We have a wastewater treatment because of this washing process. Sugar extraction. Then we have for the animal feed pelletizer, liming, sugar dissolver, filtration, steam generation, and also some packaging processes. So in all these different process steps, we can use our level measurement devices. And what we need also, we have a very universal product portfolio. So for every type of application, and the applications we can classify into three different ones. So this is what we call the UNI, so our universal product portfolio. So we have, on the one hand, uncomplicated applications, so where we need economic solutions. So these are simple storage application, and they require cost-efficient solution. The middle one are the normal applications, some standard storage or process application with higher safety or hygienic requirement. And then we do also have the intensive applications where we do need special devices. We have a demanding environment, and here we need high-class sensors with special features, designs, or approvals. And for those three types of applications, we do have our product portfolio, a wide product portfolio for solid applications and also for liquid applications. So different technologies that can use for different applications. So with our point level sensors, we have the Rotonevo, the rotary pedal, the Vibra-Nevo, vibrating fork technology, also the Mononevo, and the vibrating rod, and the two capacitive probes, Kappa-Nevo and RF-Nevo, that can be used for solid applications. And we do also have level transmitters, so for continuous level measurements, radar technology, Nevo Radar, Nevo Guide, and also the Nevo Bob. And on the other hand, for liquid applications, we do have, for the point level sensors, capacitive technology, and for the level transmitters, the Nivo guide, guided wave radar, and the capacitive technology. So, and with this product portfolio, with these different technologies, we can solve many applications in the sugar industry. And what we did, or what we already solved, will be presented now by Julian.
So, hello everybody, and welcome also from my side to this webinar today about the sugar industry. As Nicolas mentioned, we do talk about different applications today. We do start with a storage. So on the left-hand side of the slide, you see there's a storage vessel, and U stands for uncomplicated. So what we are having here, it's a small storage tank. This tank is sitting indoor, and the material is dry sugar here. We do have a demand alarm for a storage control here, as on the storage side. And it says uncomplicated because we do have a sensitivity of sugar with 490 grams per liter and a very low decay value. This low decay will pass through the complete presentation. So we have some tricky applications where we, of course, find a solution. And here in this application, it needs to be food required. And we also need a food conform rod material here from the Mononivo. Of course, it's stainless steel and an adjustable sensitivity. Why it is easy? Because in this application, we could also use a rotary pedal. We can use a VN. The solution here, or the customer decision, was a Mononivo. It would also be possible to go for a copper Nivo or also for an RF Nivo. Here in this 3-meter high vessel, there could also be another solution for continuous level measurement. What would perfectly fit here? Here we go. Sorry. A redundant system here with a perfect solution with a Nivo guide 3 series. So the series for the solid application. So continuous level measurement. We have a quick response time, and it also made for small vessels, because on the Nivo guide we're having a small dead band with a few centimeters. If you compare these with the Nivo radar, for example, we have a 0.5 meter. So that would increase the safety, and you have a 100% level control here in this application. So these both UWT devices would perfectly fit together here in this application. Another storage application, and now it's getting a little bit normal, but we see why it's not an uncomplicated, why we consider it as a normal application. So it's an outdoor sugar storage, and we solve these with a Nivo radar. So continuous level measurement, decay value stays 1.8. It depends on how the humidity is inside. So it can be from 1.6 to 2.2 also in the sugar industry. So, and we need food requirements here, and the material is sticky and abrasive. And we also have changing properties of the different sugar varieties. And here we do have a high silo, and this is why we consider it as normal, because we need to take a look on how high the silo is and what is the decay value of the material. When you have a really high silo, 40-50 meter, and then a decay value of 1.8, it can be tricky. We need to test it, but I'm very optimistic that we do also find a solution here. So point level measurement is not required here, and the solution was a Nivo radar. Would also work here would be a Nivo guide and also the Nivo Bob, so the plumb bob system here. The customer decided for non-contact radar. No calibration is necessary. You can do the calibration on the PCB on the unit itself. No material contact here, and it also waterproof housing, IP68, because the silo on the right hand side on the picture is sitting outside. and we do have a reliable measurement even with a low decay value. The next step is T, so transport, and we also take it as a normal application. So we have a small buffer silo with a dry sugar, and here we do have a high and a low level alarm for optimized material flow. We do have this density stays 490 gram per liter, and it's also food requirement. What we're having here is abrasive material and a high material flow and a small process connection. This is the reason why we went also for Mono Nivo 4000. It could also be possible to go for a RF here, CN4 not, because on the left-hand side you see how a CN4 looks like when it's sitting in the material flow. We have a foot conform rod material. We do have a compact design and then a fast response time. An RN was dismissed here because we had a 1 inch process connection here. The next one is also transport, and we did it as a normal. It's a buffer tank, also dry sugar. And we need here a detection of material flow interruption and the control of a level, the level of a blockage here. Density normal, decay value 1.8, and we do have limited space here. And limited space, why limited space outside? We'll see it on the other side, on the next slide. And was also possible to go with a Mono Nivo 4 series here, because we had also foot conform rod material, adjustable sensitivity, a compact design with 1 inch process connection, and a fast response time. Here, this is what we said about the limited space outside. We have two possibilities here. We have a separate housing here where the installation of the material is close to a silo wall or close to the next silo. We do have here Vipa Nivo 1020 here with a separate housing. So you see here from the beginning or from the end of the process connection until the beginning of the cable, we only have 60 millimeter. And also for the Mono Nivo, from the beginning of the process connection until the end of the housing was 122 millimeter. So that was fitting perfectly here. We do also have possibility to have a separate housing with the RF3000, but the RF3 is made for minimum 240 degrees Celsius, and we do have a temperature extension that stays all the time. So we couldn't use the RF3 here. And for liquid application, we do also have two possibilities: the CN7, the integral cable version, and also for the Kappa Nivo 8, the remote version. Next one, transportation, and also a normal application is a transport pipe here in the sugar industry. So we have the dryer, then that goes directly into the silo and then to the service center. And what we're having here is a transport pipe for the packing machine. Sorry. It also needs to be foot conform material, a compact design, and a quick response time. Why we couldn't use an RN here? Because we need a fast response time. Normally you're having 1 revolution per minute from the RN. Of course, we can also go for 5 revolutions per minute, but the response time from the vibrating fork is way better. Then CN, so we learned on the slides before, do not use the CN when it comes close to the filling stream or in the filling stream. And for the RF was dismissed because of limited space. Now we're coming to the intensive application in the extraction tower, so a buffer silo. We do need a high and low level alarm here to detect the material flow interruptions. So when it's sliced, it goes to the extraction tower with water. So we're having here decay value of the beet pulps more than 5, and it also needs to be completely fluid requirements. We do have a high humidity here, and we do have sticky and heavy products. So mechanical forces are also very high here in this application. So what could also be possible to go for a RN unit here, that would also work. So we didn't go for the VN or the mono-nevo, so by the vibrating technologies, because we do have sticky materials, and then there could be a problem that material sticks on the probe and is not giving the right signals. The CN or here is also not possible here because we do have high mechanical forces. And the customer decision was an RF here because it's food grade, it's ineffective by material build-up because of this active shield technology. And we do have a high sensitivity here. So on the screen, you can see two blue UWT devices that has the property or the work to control the silo. And there's also one other brand, but I think that's only a safety device. So the blue one has two safety properties to go for the silo and also to control the other unit. The next one is the exits, and we consider it as a normal application. So it's a storage silo with limestone, because we learned that from limestone, after a chemical procedure, it goes to fertilizer. So that also be important here to mention this in the food industry and the sugar. We had to have a dusty atmosphere. We do have sticky materials and also a low decay value. Of course, the low decay value depends on how big the sizes of the limestone is. Here we solved this with a NevoBob 4000 series. It could also be possible to go for a radar here, because recently we had a project in Sweden where we solved also an application with limestone with Nevo radar. But here with the NevoBob, it's unaffected from the decay value and also no build-up on the probe, because it's always comes with a tape cleaner. We do have a measurement range up to 30 meters and a reliable and cost-effective solution here, especially with the option of the Modbus. The next one for exit and aggregates here in the storage, and it's also a normal application. It's a cyclone hopper, so a storage silo for animal feed production, and we do have a low level alarm. This application goes up to 150 degrees. We do have an X area and a dusty atmosphere, and also the material is very light because it's not pelletized yet. So we could use also an RN up to 600 degrees, because that's we also have the option to go to 1100 degrees from the RN, but then you are only allowed to mount it from the top. And RF would also be possible here. The next one is the processing of the sugar, and we do start with an intensive application. We do have the dissolvers vessel here and the different viscosity of the syrup of the sugar. So the increased level control with the redundant level measurement system. So we need one UWT unit for all different viscosity syrups here. So still we have very sticky material and a huge buildup. So the more viscous it gets, the more buildup we do have. And the customer decided to go for a Kappa Nevo 8 series here. So we had one sensor for all different tanks. It's ineffective now from the buildup, and it's also a challenge here that we need to ignore the foam. And this is possible with the CN7 and also with the CN8. I will show you a short video how a huge buildup of the CN7. So it's a CN7, and the customer decided to go for a CN8, but the electronics is the same, and how we can ignore a huge buildup on the CN7 here. So it switches in water here. And now what we did here with butter to simulate a huge buildup on the probe. and it still stays uncovered. When it comes in contact with the water, it switches again to covered. So you see, even with a huge build-up, the unit is working really reliable due to active shield technology. What we're having here, animal feed production, and also a difficult application. So it's a universal process tank. And the challenge here is that we have changing contents. So different materials, we have molasses, we have vinasse, we have oils, we have fat, we had beet pulp, so everything mixed together. So we need to ensure the correct amount of medium is added according to the recipe here. And we solved this application with a CN7 capacitive probe. So it needs to be foot conform, a compact design, unaffected from buildup, and no international individual adjustments to each component is necessary here. So the customer used a vibrating fork, but it's not working reliable due to the huge buildup, and we changed to Carbonibus 7 series, and this is working perfectly. This is what we already recommend when you would like to exchange a vibrating fork, go for the CN7. And the last application here, animal feed for the process industry, and we consider it as a normal. It's a pelleting machine. We do have the beet parts, and here in this application, we do have a high and a low alarm. And we do need a material blockage detection. And what we're having here is sticky materials. We do have high humidity, and it needs to be completely food requirement here. So it was standard. So the customer went for a Roto-Nivo 3 series with food conform materials, and needs to be unaffected from buildup. And Roto-Nivo is of course unaffected from buildup. What happens when you have buildup? It only makes the vein bigger, and a bigger vein only increases the sensitivity of the unit itself. So what we said, sugar beet, it's universal, like UWT devices. You can use it almost everywhere. Also, the sugar industry, it's everywhere. Sugar is in lemonade, in ketchup, yogurt, also in bread. If you see the brown crust in the bread, that comes from the sugar. Also, pills, medical substances also have a small ingredient of sugar. The sugar beet goes to electricity in the heating, in vinasse, also for the alcohol production, it's important. Fertilizer, animal feed, you see, it's almost everywhere. And this is why we also said, what do they have together? So the sugar beets and UWT, they are all around. You can use them almost everywhere. And I would also thank you, all the partners and distributors providing me this application, because this is, I need to say this every time, we can only lead from each other. And if you provide us the information about the application, we do profit. We do profit from the money, and also profit at the end from experience. When customers say, are you having any information about these? Go to the UWT application database. It's really unique. You find many applications, and this grows every day. Every day we're getting more information, and we are getting better also from the knowledge from the industries. So I would like to pass to Nicolas for the last slide, because he is having also another announcement. Maybe you have seen these, but Nicolas will say 1 or 2 words on the last slide. From my side, thank you very much for listening, and we do see each other on the next webinar soon.
Yeah, thank you, Julian, for this interesting overview of all the applications we did in the sugar industry. I hope we could give you some more information, some helpful information, what is happening in the sugar industry, what applications we have, and I hope it was helpful for you. And now my announcement. So there will be another webinar on the 4th of March. And in this webinar, we will go more into detail to one technology. So we will talk about TDR sensors, so the guided wave radar sensors, with some technology explanations, where to use those sensors, how they can deal with different types of applications. And I would be happy if many of you guys join there. It's the 4th of March, 11 a.m. It will take around 30 minutes again. And I hope that you will register for this webinar for the next session. So this was the announcement. And now I think this is what we can say, that you with UWT always in good hands. And thank you also from my side for your time, for listening to this webinar. And maybe if you do have any feedback for us, it would be very good for us to hear those feedbacks, if you liked it, if you didn't like it, and what we could improve for the next sessions, what we will do in there. So thank you and have a good week, and we will see us